I'm here with Stuart Kauffman. It's a great pleasure. He's a very nice person, but besides of that, great mind with great ideas. He has graduated from Dartmouth and also has an BA with honors from the Oxford University, and later he went to complete also a medical degree in the University of California. Nowadays he's based in Santa Fe. Many papers, many books, very interesting ideas. He presented a talk to us yesterday here in the Second International Congress on Consciousness that was quite intriguing, kept everybody engaged, very broad topics. Let's see what we can learn from him about that. But first, Stuart, thank you very much for being with us. I would like to hear a little bit how you got interested in studying about consciousness, non-locality. How does that started?
Gosh. I guess it started when I was at Dartmouth. I graduated in 1961, which makes me demonstrably older than you, Nanci. And I was interested in the mind-body problem then, and I went to Oxford to work on the mind-body problem. So I've been interested in it essentially since I was a young adult. Then I went into medicine, and then I went into theory and biology. And about 1995, I came back to the mind-body problem. Because I knew some of the outstanding problems with the mind-body problem. I found out some features of quantum mechanics that I thought might help answer the ancient problems since Descartes about, Descartes gave us res cogitans and res extensa, substance dualism, and the problem since Descartes and Newton has been, that's fine, but how does this res cogitans act on res extensa? Apparently the Princess of Sweden asked Rna the same problem. He couldn't answer it. He thought it was the pineal gland. And it is for that reason, the substance dualism of thinking stuff and matter stuff, which Newton then took to classical physics, which has been the stalemate. We've been stuck here since Descartes and Newton. I saw the beginnings of some ways to try to solve that problem in 1995 when I found out about quantum mechanics and something called decoherence. So I've been thinking about it since then.
Yes, and in terms of inferring non-local consciousness from your personal life, you were telling me about some of your experience. If you don't mind sharing with everyone,
no.
I think it's interesting, shows a little bit of the background of some of the ideas.
If what I experienced was what I think I experienced, it was non-local. It was probably telepathic, or not. It was extraordinarily painful. I delivered my daughter, Merritt, in 1963. My wife Liz was very sweet. She said, "Go ahead." And then she said, "Is the real doctor there? Could the real doctor please finish?" So I delivered Merritt. And when she was 13, we were living in Philadelphia, and I picked Merritt up at her boyfriend's. I did not want Merritt at 13 to have a boyfriend.
I see.
Merritt wasn't going to listen to her father. And she said, "Daddy, I'm going to walk home from Alex's house." Well, any father of a 13-year-old daughter would be worried.
Yeah, of course.
Because I thought it was about 3 miles. It was actually 5 miles. And I picked her up, and we pulled out of Alex's driveway, and then we pulled onto a slightly larger street. And I was absolutely dumbstruck with terror as we drove past a tree, and I saw Merritt walking down the middle of the lane, being hit from behind by a car, and crushed. And I was terrified. And I said, "Merritt, don't ever walk home from Alex's house. You call Mom or me, day or night." And Merritt was silent, and I thought, I'm having an argument with my teenage daughter. I think I'm going to lose this one. She's entering a dangerous period. If she makes it to 16, she'll be fine. Then she said, "Don't worry, Daddy. If I walk home, I'll call you from the Roy Rogers up here." I said, "Well, that's an okay compromise." But a month later, Merritt was over at Alex's. He broke up with her. And Merritt walked out, and she did almost what I said. She was walking sort of down the middle of the lane and was hit from behind by a car, not quite, but approximately, and killed on the very spot where I saw it happening. And I haven't gotten over it. It was 32 years ago. So I can account for being worried, because any parent would, but I can't account for the specificity of that image.
Yes.
Nor can I account for the fact that the next morning I called a woman named Linda Haley. I've known Linda since she was born, and I was 3. And I told her that Merritt had died. She said, "My God, last night I had a dream that you were crushed and crumpled in grief on your dining room floor, and Liz, my wife, was behind me holding me.
Yes.
And then it wasn't me. She said, I thought you were dying. Why did Linda have that dream? We hadn't talked to one another for 8 months, and she was 2,000 miles away. Well, okay, these things happen sometimes. I don't think so. I think that's
too much to be a coincidence.
I think that's real.
Too many
So to jump ahead, I think telepathy is possible.
Yes.
If the mind-body system is quantum in classical, which I think it probably is, then via non-locality, which we can get to, I think that something telepathic can happen. And it's going to be very evanescent because it relies on entanglement, and entanglement is very evanescent.
Yes.
So getting reliable, stable data is going to be very hard. But if we don't take it seriously, I think we're just being stubborn. Particularly now we know that quantum biology is real. So we don't know how much of biology is quantum, but my bet is that it's more than we think.
So that's why you started trying to see biology from the point of view of maybe mixing a little bit with quantum mechanics and seeing the mechanisms of all of it, maybe to explain consciousness and phenomenon of awareness.
Well, so I don't think we can explain what consciousness is.
Yes.
Okay, I think David Chalmers is right.
Yes.
I think that
At least not at this point.
not at this point. Right?
Yes.
But I think that quantum mechanics offers ontological grounds to account for things that we want of consciousness that classical physics can't.
Yes.
So I'll just tell you briefly what I learned in 10, 12 years ago. If you have a coherent quantum system, it can decohere to classicality for all practical purposes. But that decoherence process is not causal. The system just loses phase information. Well, that begins to sound like a quantum mind could have acausal consequences for the meat of the brain. That's wonderful. Descartes didn't know how to do that because in classical physics you can't. Classical physics has all the causal features already in it. It's the causal closure of classical physics. And honest to gosh, in 1995, this is just wonderful. And I think when I gave a talk, I talked about a pink sheet that goes gray in certain areas and pink again. Going gray is pink is quantum coherent and gray is this image, decoherent and classical. That's great, but it'll only happen once. So I just invented, I honestly did let it get pink again, recoherence. And it turned out I was right, that intuition is right. A decoherent quantum system can become coherent, quantum coherent again. It's called recoherence. It's assured by a theorem due to Peter Shor, and I think it's been observed experimentally in light harvesting molecules. And if that can happen, a quantum poised realm classical mind can be quantum, decohere to classicality through the poised realm to classical for all practical purposes, recohere back through the poised realm to quantum over and over and over and over again. So a quantum poised realm classical system is such that the quantum aspects of it, which is both quantum and poised realm, can have repeated acausal consequences for the meat of the brain. I think that answers Descartes. That's already enough.
Yes.
We have lived with Descartes and the problem of the stalemate for 350 years.
Yes.
And I think this answers it, or at least it can answer it. And the poised realm is real, and I didn't really stress that very much in my talk. It's real, Nancy.
Yes,
Okay?
I see, yes. And I mean, and we do need a new model to allow us to study all of the different aspects we are seeing nowadays about consciousness and even about the brain.
Yep.
Because there is so much there, and when it comes to explanations, it's all restricted and funneled to all the same old explanations. I feel we are entrapped into that in the scientific maybe design we have nowadays. And so it's very interesting that we bring these ideas and we hopefully get to a point that we are more open to study all of that. Stuart, you mentioned about complex systems, which I understand partially. Maybe you help to enlighten me and everyone else who is hearing to this and they do not understand as much as I don't. But also the connection of that with the origin of life, because you as a theoretical biologist, I'm very curious to hear what you have to say about that.
Well, thank you, Nancy. So in about 1970, getting old, about 1970 I started thinking about the origin of life, and we knew the structure of DNA at that point, and I'm sure you know it's a famous double helix.
Yes.
And its cousin is RNA, ribonucleic acid, and it too can form a double helix, in which by Watson-Crick pairing, one strand specifies the other strand through in DNA A, T, C, and G. So A's bind T's and C's bind G. So if I know the A, T, C, G on one side, I know the complementary strand on the other side. So the thought was then, and it still is, if I had a single-stranded RNA molecule with A's and U's and C's and G's lined up on one side, it would specify, if I had a set of free nucleotides, the free letters, an A would bind a U would bind an A C would bind a G would bind a C. So I would now line up the free nucleotides in solution. Then somehow magically they would link together to make the second strand, and then the two strands would melt apart. It's a gorgeous idea. The problem is it hasn't worked for 45 years.
I see.
But it might, and although it hasn't worked, it doesn't mean that it won't work. Leslie Orgel spent much of his career trying to make it happen, and it hasn't. And there's good chemical reasons. If you take two of these little nucleotides, they want to make what are called 3', 5' phosphodiester bonds, and they prefer 2', 5', and a 2' won't make the double helix. And there's a bunch of reasons why it hasn't worked so far. So people, the dominant view in the United States is the Rna World View, and it's a template replicating RNA. Well, I got to what I thought about in a very strange way, which was, suppose that the constants of nature were a little different. So you could still get chemicals, but you couldn't get carbon. But you get complicated chemicals and complicated molecules. Would life be impossible? I thought, no, it can't be. But you couldn't make DNA. So what I was really asking is DNA essential for life? And I thought, no, it's not.
I see.
It's a set of molecules that has the property that they can undergo complex reactions with one another, and they can act on one another to speed up those very reactions. To speed up a reaction is catalysis. So I need a set of molecules that mutually catalyze one another's formation. So I catalyze the formation of you out of Nanci parts. You catalyze the formation of me out of Stu parts. And the Stu parts and the Nanci parts come in from outside, so we're a non-equilibrium system. And I said, okay, that's a collectively autocatalytic set. And so I did work then, and I came back to it in 1986 and so on. And I showed that if you have a complicated enough soup molecules, they will spontaneously form.
Yes, in some way, yes.
It's a gorgeous phase transition. It's a phase transition, and I give you the image for it in a simple way. Take a bunch of buttons, put them on the floor.
Yeah.
Take a spool of red thread, has to be red. Okay. Break off a piece of red thread, pick up two buttons at random and tie them together. Pick up another piece of red thread, pick up at random two buttons and tie them together. And just keep doing that. You have 10,000 buttons, and just keep doing it. Well, at first you'll have a bunch of separate buttons and little pairs of buttons. When you get about half as many threads as buttons, the number of ends of threads, each has two ends, it's the same as the number of buttons. All of a sudden everything gets connected. Can you sort of picture it?
Yes, I can picture that in my mind. Yes.
And it is the emergence of what's called a giant component as a phase transition in a random graph. A graph is a bunch of buttons connected by a bunch of threads. Well, a chemical reaction graph is the same thing up one level. You have substrates going into reactions, coming out to products in some complicated way. If you catalyze enough of the reactions, you'll get a big connected structure. And if the molecules that are doing the catalysis are the same as the molecules that are the products of the reactions, you get a collectively autocatalytic set. So where we are on that now is, people have made collectively autocatalytic sets. They've been made, Nanci, this is really important, they've been made out of proteins. Goran Ashkenazi has a 9-peptide collectively autocatalytic set in Israel. And that proves you do not need DNA or RNA to get molecular reproduction. It's done. Nobody has yet gotten the spontaneous formation of a collectively autocatalytic set. We're kind of close.
Yes.
So just a teeny bit more. If you had that.
So right now it's like a theoretical framework, but that makes a lot of sense.
It makes an awful lot of sense.
Yes.
We're getting close to making it happen spontaneously.
Oh, that
it
would
may
be
be
an
hard.
interesting step.
Oh, it's a huge step.
Yes.
A guy named Nels Lehman has taken a library of halved ribozymes, which are evolved RNA molecules, put them in a pot, and they spontaneously make collectively autocatalytic sets. Now it's right now trying to randomize those sequences and see if it works. Now, suppose we got that. Then you better put it in something so that it's a cell-like thing, like a liposome. If you put lipids in water, they form a hollow vessel called a liposome. It's like a cell membrane. And liposomes can grow and bud and divide, grow and bud and divide. And there's good grounds to think you could put an autocatalytic set inside of a liposome, and if the autocatalytic set made the lipids for the liposome, you'd be pretty close to protocell. Mm-hmm. So my hope is that we'll do it in the next 15 years. And in fact, a group of us is meeting in September.
Mm-hmm.
We've been meeting over a number of years.
Here in the United States?
Well, no, we're going to be, we're going to suffer. We're going to be in Vienna.
Vienna.
Yeah,
so another trip for you, yeah. Right? One of many.
But meanwhile,
yes.
So far this is classical physics and chemistry.
Mm-hmm.
So when I gave my talk, I told you all about this poised realm.
Yes, yes.
Quantum biology is alive and growing. So light harvesting molecules are quantum coherent. And when I talked about this poised realm, my colleagues with me kind of holding on at the tail end have discovered something amazing. And where I'm going is, it may be the case that important quantum phenomena are going to be going on even in this protocell.
Yes.
And it's conceivable that they too will be conscious. Conceivable. I don't know how we prove it, but it's conceivable. So just one thing about then this poised realm. It turns out that molecules can be quantum mechanically conducting, or they can be quantum mechanically insulating, or they can be at the metal insulator transition between conducting and insulating. And if they're at this metal insulator transition, the wave function, I slightly understand, has very strange properties called fractal. Mm-hmm. So it's called quantum criticality. And my colleagues and I have discovered it in organic molecules. And it may, just maybe, is related to high temperature superconducting. Maybe. At nanokelvin, criticality is associated with superconducting. And at least it's extremely interesting quantum mechanically. And I'm not a physicist, I just fake it. So I think that we can maybe make protocells. I think maybe they can include molecules that are quantum critical. And then I don't know what, but it's exciting.
Yes, pretty exciting, and sounds like something that would be a big mark, a big step, yes. And maybe shocking in some ways, right?
Yes, I hope so.
Revolutionizing some of the views we have.
Yes.
That is so nice. Is there anything you would like to finalize with? Stuart, are you okay with the information you have passed? Would you like to add anything?
Just a teeny bit. In my talk, I tried to talk about why I think you can account for non-locality. That's a huge subject, and
yes.
You have my paper on it.
Yes.
If non-locality is real in physics, there's no doubt about it whatsoever. It's if you take two entangled variables and they're space-like separated, mm-hmm. If one is measured instantaneously, the other will be measured in a correlate. If one's up, the other's down, for
yes.
example. I hope that I have one account for it that was related to what Heisenberg came up with in 1958. In any case, non-locality is real. If the mind-body system is in part quantum, and in part poised realm, and in part classical, we can maybe make something I want to call trans-Turing systems, mm-hmm. that are not algorithmic computers. Computers are subsets of classical physics. Discrete state, 0, 0, 0, 1, discrete time, t plus 1. A system that's quantum, poised realm and classical, isn't algorithmic. I don't think the human mind is limited to being algorithmic. I think we could maybe make something that I'm calling a trans-Turing system. It could be as big as computers, and they could be entangled. So we could have non-local connections, and it'd be like my daughter and me the day that I interrupt.
Yes, I see. Yeah. Wow. Lots of different, opportune and important things to mention about. Actually, I want to mention to all of you that want to see the full paper from Stuart Kauffman. It's going to be published in the Second International Congress of Consciousness Proceedings. So it's going to be soon available. Thank you so much.
Thank you.
I wish we had here 2 hours, because some of the ideas you mentioned, I want to explore more. But it was absolutely clear, and I'm sure everyone will cherish. Thank you so much for your time.
Thanks, Nanci.
It was a great pleasure.
Thank you for inviting me.
Thank you.